Okay. Now we come to something that's called the continuity correction. And the idea is that we are dealing with something perhaps which is inherently discrete. And we're going to use a continuous distribution to approximate some discrete distribution. And when we do that, certain errors would be introduced, of course. And people have looked at how you would go about minimizing that error. And this is something that's called the continuity correction. Okay. So here's the idea. You have some x is equal, you want the probability that x is equal to n. Now, a table of z values, for example, is the PDF for the normal distribution. Or sorry, a table of CDFs for the normal distribution. It's not going to give you that, right? So what do you do when you want the probability that x is equal to n, which you are approximating by a normal or by some other continuous distribution? Okay, well, you would take the probability that x is between n minus 0.5 to n plus 0.5. Okay, so the probability that x is equal to n, if you want to approximate it by a continuous distribution, then you look at this. You look at the probability that x varies between n minus 0.5 and n plus 0.5. If you want the probability that x is greater than n, then you use in your approximation from the continuous distribution, look at probability that x is greater than n plus 0.5. If you want the probability that x is less than or equal to n, then look at the probability that x in the continuous approximation, look at the probability that x is less than n plus 0.5. If you want the probability that x is less than n, then the continuous approximation should be given by looking at the probability that x is less than n minus 0.5. And if you want the probability that x is greater than or equal to n, then look at the probability that x is greater than n minus 0.5.